Hello and welcome to the Alaska Ocean Acidification Network's Ask a Scientist series. This series answers questions from real people like you with the help of ocean acidification experts from the network. Our question today is, can ocean acidification be slowed down or reversed? And here to help us is Brad Warren, the founder and director of Global Ocean Health, which is a program of the National Fisheries Conservation Center. So I'll turn it over to you, Brad.
Hi, thank you for having me, Darcy. I guess the question today that you asked me to look at is, can ocean acidification be reversed or slowed down? And I'll just go ahead and pounce on that and say, I'll answer it in several ways. Yes, absolutely. Nature does it all the time. It just takes a really long time. That's what weathering does. Alkaline rock washes down into the ocean and takes care of it. But we humans have altered the ocean's chemistry faster than weathering works, and it's not keeping up. So then you get to question two, can we do this on human timescales? And the answer is yes, through emission reduction, which is what every serious body looking at this and saying, what can people do about it? They've all said, do emission reduction. So yes, we can. And maybe through drawdown, which is something else a lot of people are interested in, using forests and farms and growing things to sequester carbon through photosynthesis and soil building and things like that. Those things work. I think there are open questions to be resolved about whether we can do it fast enough, and there's some pretty hopeful evidence that we can move it very fast. And then finally, there's a third response, which is at local scales, almost at the level of adaptation. We can do things to reduce harm. We can engage in local remediation. We can do things, for example, like growing kelp forests and kelp farms. There may even be things using eelgrass and salt marsh and mangroves. I think the jury is out on how much difference those can make and how fast they can make it, and whether they can be sustained over time in a changing ocean where the coasts are profoundly physically altering their habitat with sea level rise and things like that.
So do we know what degree of emissions reduction is necessary to actually turn this ocean acidification process around?
There's really no question. There's enough momentum in this system that we are now engaged in harm reduction. Some of the impacts are here today. Some of them are baked in and are going to get worse. Ocean acidification in the upwelling region of the West Coast, for example, is going to continue to get worse for some time. And the modeling suggests that if we hit aggressive reduction targets, we can turn it around before it gets to be an ocean we don't know anymore. But not taking on that problem commits future generations to an ocean that doesn't make the kind of food we've had the pleasure of eating for something like 3 billion people who get a significant portion of their protein from the ocean. That could end.
You referred to some success stories on the East Coast about emissions reductions on a large regional scale. Could you tell us a little bit more about that?
Yes, both on the East Coast and in California. There are now 10 states that have quite good policies that are performing well. California, of course, has its emissions trading system, and there's a similar emissions trading system in 9 states on the East Coast. More states are looking at joining it, in part because it's economically viable as well as environmentally. And in both of those systems, they have outperformed their emissions targets, and they're racing forward faster than anybody thought they could in reducing emissions. In the region from Maine to Maryland, the 9 states that have this system called the Regional Greenhouse Gas Initiative have reduced emissions from power plants since it implemented in 2009 by more than 50%. It means that we have one sure bet, which is reducing emissions. That works. And we now know how to do it so that it actually delivers. And then we have some very speculative hope that we might figure out how at the last minute to pull some heroic reversal. And, nature works on long-term averages a lot of the time. And as we alter the long-term average chemistry of the ocean, we're starting to see profound harm to things we like to eat and things we like to see in the ocean. And it's probably not a smart bet to assume that somehow we will magically overcome problems that are altering the entire ocean, when we may know a little bit about how to change things in a bathtub or a spawning tank in a hatchery. But the ocean as a whole, it's a lot bigger than we are still. And we have achieved a scale as humans where we can alter its fundamental chemistry, and we're doing it. And our ability to reverse that, it depends primarily on reducing emissions.
Brad, thank you so much for being with us today for Ask a Scientist. For all our listeners, we hope that you will submit more questions, and we'll see you next time.